For our second example in section 7.2 on circles, we've been given the following equation: 2x squared plus 8x plus 2y squared equals 18y plus 3 halves. And we're told, rewrite the equation into the standard equation for a circle, then determine the center and any x or y intercepts, and then graph that sucker. So as it stands right now, this formula does not look anything like what we talked about previously in our standard equation. That is to say, x minus h squared plus y minus k squared is equal to r squared is our standard equation. But this does not look anything like that. So what are we going to do? Well, whenever you're dealt this hand here, well, the first thing that you want to do is get all your x's and y's on one side of the equation. So that's going to look like this: 2x squared plus 8x plus 2y squared minus 18y is equal to 3 halves. And then what we're going to do, which is very similar to what we had talked about for parabolas too, we're going to complete the square in each variable. So that's a little bit different. We're going to do it once for x and once for y. So let's take a look at that. Let's see. Let's do the completing the square for x first. I guess we can do it at the same time with y. Let me just color code this so that it doesn't get too confusing with what we're doing. So the first thing that you guys should remember when completing the square is you need that leading coefficient to be a 1 in both cases. So we're going to factor out the lead coefficient, but I'm going to really keep these separate. This is 2 times x squared plus 4x, quite separate from the 2 on the y squared minus 9y as we factor this. And then this is 3 halves on the other side. So quite separately we have these two here. Now, once we factor out the leading coefficient, 2, we're going to add the magic value inside each parenthesis. Okay, so how do we find that magic value? So if you guys don't recall, what we're going to do is we're going to take, I want to color code that correctly. We're going to take the coefficient on x with this factored value out front taken out. And that's going to look like this. We're going to take 4. We're going to cut it in half. That is going to give us 2. We're then going to take that value 2 and square it. So cut the x coefficient in half, then square it. And that's the magic value, and that's going to give us a value of 4. And so that's the number we're going to add in to this set of parentheses. Now, that was a coincidence that we started with 4 and we ended with 4. Maybe I should have done that at the bottom. Hold on a second. Let's see here. Let me copy this guy. Duplicate. So it's a little bit easier to look at later. Okay, so this 4 becomes the plus 4 here as we color coordinate. Okay, now to find that other magic value for the y's, we're going to do the same thing, but we're going to do it in lavender, man. So we're going to take our lead coefficient. That's a negative 9 on y, not our lead coefficient, excuse me. The coefficient on y, our linear coefficient. And we're going to drag that down here. We're going to take negative 9. We're going to cut it in half. I'm not going to write that as a decimal because I'm going to have to square it. So that's why I really prefer fractions here, because it's a lot easier to just square the numerator and square the denominator. And so that's the magic number that we're going to add in to this set of parentheses, plus 81 over 4 here. Now, the kicker is this. In order to keep this equation balanced, we have to add the same thing to both sides here. So let me move this over a little bit so I got some more room here. Don't forget, to balance the equation. So what does that mean? Well, we added in 4 here, but we didn't really add in 4. We actually added in 4 times 2. So if we add in 4 times 2 to the left, we're going to have to add 2 times 4 on the right side. And over here, we added in 2 times 81 over 4. So plus 2 times 81 over 4. So we have to balance the equation. Watch out. Now, as we simplify this, step 3, factor and simplify our mini step here. Now this is 2 times something squared plus 2 times something squared is equal to, let's see, this is 3 halves. 2 times 4 is 8, which is 16 halves, plus 81 halves. And that's 100 halves, which is 50. Now, pay attention here. I say factor, but you don't really have to think at this step. It's always going to factor as x plus or y plus half this linear term. So in this instance, half of our linear term was 2 for x, and half of our linear term was 9 halves for x. So while we used it here and squared it, we're also going to use that value again. This is x plus 2, and this is y minus 9 halves. So those values here are also related to the magic number. And then to put it in standard form for step 3, our final step, let's see. Real step number 1, real step number 2, complete the square in each variable. And then step number 3. Get the standard equation, which we'll just divide by 2. And we get x plus 2 squared plus y minus 9 halves squared is equal to 25. And so, with that standard equation, we can begin to answer some questions. So, number 1 here, or the first thing that we were asked for, if we go back up top. Determine the center, x and y intercepts, and then graph that sucker. So let's go back and do that in order. The center, C, is the h comma k values. Here, this is actually x minus negative 2 squared plus y minus 9 halves squared is equal to 5 squared as we rewrite that. And so the center here is the h value, which is negative 2, and the k value, which is 9 halves. So I am putting this in the appropriate form to read it. And then the radius, r, is equal to 5. Okay. Now, for the x and y intercepts, remember that for the y-intercept, we set x equal to 0. So what will that give us? In this instance, we'll get 0 plus 2 squared plus y minus 9 halves squared is equal to 25. If we square this term, it'll give us 4. And if we subtract 4, we'll get y minus 9 halves squared is equal to 21. Or y minus 9 halves is plus or minus the square root of 21, which means that our y values are 9 halves plus or minus the square root of 21. So we have 2 y-intercepts, and they are 0, 9/2 plus the square root of 21, and 0, 9/2 minus the square root of 21. For our x-intercepts, we're going to set y equal to 0, and that's going to give us x plus 2 squared plus 0 minus 9/2 squared is equal to 25. That's going to yield x plus 2 squared plus 81 over 4 is equal to 25. I'm actually going to rewrite that as 100 over 4 so that I have a common denominator. That way when I subtract, this is x plus 2 squared is equal to 19 over 4, which means that if I take the square root of both sides and subtract 2, I get x is equal to negative 2 plus or minus the square root of 19 over 4, which can be simplified just a little bit as negative 2 plus or minus the square root of 19 over the square root of the denominator, and the square root of 4 is 2. And so we also have 2 x-intercepts, and they are negative 2 plus the square root of 19 over 2, comma 0, and negative 2 minus the square root of 19 over 2, comma 0. So they're not super friendly looking. So let's recap here. We have our center. We have our radius. And we have a couple of y-intercepts and a couple of x-intercepts. Now, I'm not going to worry too much about graphing those per se right out of the gate. I'm really just going to start with the radius in the center. So let's take a look at this here. Let's see. How big do we really need to make this? Let's make it as large as we need to here. Let's see. Let's move that over a little bit. Something like that. A little bit longer. There we go. So let's see. Our center is at negative 2, 9/2. So let's see. Negative 1, negative 2, 1, 2, 3, 4, 5. 9/2 is 4.5, so that'll be negative 2, 4.5. There's our center right there. And then we're supposed to go out 5 units in every direction for our radius. So let's see, let me get back here. 1, 2, 3, 4, 5 in the x direction. Negative 3, negative 4, negative 5, negative 6, negative 7, negative 8 in the other x direction. And then maybe up as high as 5, 6, 7, 8, 9. Hopefully that's enough in the y direction. And let's see what we got here. So we'll go 1, 2, 3, 4, 5. Whoops, 1, 2, 3, comma 9/2 will be 5 units to the right. R equals 5. We'll go 1, 2, 3, 4, 5 units to the left. That's another R equals 5. We'll go 1, 2, 3, 4, 5 units down. And we'll get our low point, and we'll go 1, 2, 3, 4, 5 units up to get our high point there. And then, of course, that is R equals 5 in the vertical directions. Hopefully I haven't screwed this up too bad. I'll try to draw a circle. See how this goes. With the magic of technology, boom, that wasn't too bad. Yeah. Something like that. So there's our circle. We do have our x and y intercepts. Let me extend this y-axis just a little bit. So let's see. I'll do those in blue. We have 2 y-intercepts. This one was 0. 9 halves plus the square root of 21 is the upper one, and this was 0, comma 9 halves minus the square root of 21 must be the lower one. And, ooh, those are all really close together. I better move that. Let's see. Let me erase that. This y-intercept down here is 0, 9 halves minus the square root of 21. We also have a couple of x-intercepts. Let's do those in a different color. Man, those two intercepts are really close together. Let's see. This is the larger of the two. This is negative 2 plus the square root of 19 over 0, excuse me. And this guy here is negative 2 minus the square root of 19 over 2, comma 0. Can you fit it all on here? Not all of it. Anyway, that is our result.